The next one is the pair of quantities having same dimensions is. Okay, that is out of these four options, we have to identify which pair is having the same dimensions. Displacement and velocity. Okay. Though the question is very clear, but I am telling you how generally what should be the steps to solve such type of questions. Okay, so displacement and velocity. Obviously, two different physical quantities or two different types of physical quantities. Like for displacement, dimension is L and velocity is meter per second. That is L t minus 1. This cannot be the answer. Second, time is t and frequency is 1 upon time period, that is t minus 1. Different dimension, cannot be the answer. Third, wavelength. Wavelength is L, that is lambda. Focal length, again length, that is L. So this is the correct answer. Good. Now let's talk about this force and acceleration also. Force is ma, mass into acceleration, and acceleration is obviously acceleration. So from this expression, it is clear that the dimension of force will be equal to m into a, the dimension same as m into a, and the acceleration is having a dimension as f by m. Good. So I am writing the dimensions of f, that is mass into acceleration. So m, acceleration is meter per second square, that is Lt minus 2. Now for acceleration, it is meter per second square. Good. So this cannot be the answer. So option number third is the correct answer. The next one is the relation between force and density d is F equal to x by root d, where F is force and d is the density. The dimension of x. Okay. So from this expression, as it is known to everyone, that if you have a physical relationship between different quantities, then you can find the dimensions. Okay, that is for x. How you can represent x? X as f into root d. So if we have a mathematical relationship, then we can write the dimension formula. Okay, so x, force is ma, so m is m. A is acceleration, that is meter per second square. Okay, now root of density. Now density is equal to mass upon volume. So mass is m and volume is L cube. So d is having a dimension of m L minus 3. Got it? So here it is not d, it is root d. So it will be m L minus 3. So we can write as x as m L t minus 2, m power half and L power minus 3 by 2. Good. So x is having a dimension of, now look at mass, m1, m power 1 by 2. So it will be m power 1 plus 1 by 2. Now comes L. This is L power 1, L power minus 3 by 2. So it will be 1 minus 3 by 2 and t minus 2. Got it? So x is having a dimension formula of m 1 plus 1 by 2 is 3 by 2. So it is 3 by 2. L power 1 minus 3 by 2 is minus 1 by 2 and t power minus 2. Got it? So this is the dimensional formula. Just identify where it has been written here. M power 3 by 2, L power 1 minus 1 by 2 and t power minus 2. That is option number 1 is the correct answer. Just recheck because the options are very similar. M power 3 by 2, L power minus 1 by 2 and t power minus 2. So option number 1 is the correct answer. Next one is, an athlete completes one round of a circular track of radius r in 20 seconds with constant speed. What will be his displacement at the end of 1 minute and 10 seconds? Okay, he completes one revolution in 20 seconds and the question is asking its displacement at the end of 1 minute and 10 seconds, that is after 70 seconds. Okay, 1 minute 10 seconds is equals to 70 seconds. Okay, let's suppose A is the starting point and after 20 seconds, athlete reaches at A again. Okay, so time is 20 seconds. Now again, to complete the next one revolution, it will take 20 seconds. Then after 20 seconds, it completes. He has completed third revolution. That is at the end of 60 seconds. He has completed 3 revolution. Then as the athlete is moving with constant speed, so if in 20 seconds he completes 1 revolution, then how much he will complete in 10 seconds? That is half of 20 seconds, just half of the revolution. So he will reach at point B in last 10 seconds. In last 10 seconds. Okay, here 1 revolution, here 1 revolution, here 1 revolution, but here only half revolution. After completing 1 revolution, displacement is 0, displacement is 0, displacement is 0. But because of this half revolution, he will reach exactly at the opposite end. So this will be the displacement. So radius is R, so displacement will be equal to the displacement, the diameter, not displacement, diameter, and that is equal to 2R. 2R. That is option number 2 is the correct answer. Got it? Next one is the speed at the maximum height of the projectile is √3/2 times of the initial speed u of projection. Its range on the horizontal plane is, okay, let's suppose the particle is projected like this with velocity u, initial velocity u at an angle theta. Now velocity is a vector quantity and every vector quantity has its component. So this is u cos theta and vertical component is u sin theta. Okay. Now at the highest point, vertical component will become 0, but the horizontal component remains u cos theta. Because there is no force acting on the horizontal direction, so horizontal force remains unchanged during the whole motion. Now the question is saying the speed at the maximum height, which is equal to u cos theta, that is equals to √3/2 times of the initial speed u given. Okay, so u will cancel u, so cos theta is equal to √3/2, that is theta is equal to 30 degree. So we have got the value of the angle of projection. Now the question is asking the range, that is horizontal range. So horizontal range, and horizontal range is equal to u square sin 2 theta by g. So r is equal to u square sin 2 into 30 degrees upon g, that is u square sin 60 degree by g, and this sin 60 is √3/2, so range comes out to be √3 u square by 2g. √3 u square by 2g is the horizontal range, that is option number 1 is the correct answer. Next one is, a man is 45 meters behind the bus when the bus start accelerating from rest with acceleration of 2.5 meter per second square. With what minimum velocity should the man start running to catch the bus? Okay, for these type of question based on catching, overtaking, we should draw the figure. Okay, man standing here, this is the bus. Okay, and man is standing at a distance of 45 meters behind the bus. This is bus. This is t equal to 0. This is t equal to 0. Now bus, he starts moving with velocity, let's suppose v, and this v we have to find out. And from the question it should be clear that the man keeps moving with the same velocity, that is his acceleration is equal to 0. While bus starts from rest, that is initial velocity is 0. and the acceleration of the bus is equal to 2.5 meter per second square. This is the scenario at t equal to 0. Let's assume that man catches the bus after time t. So after time t, there is a bus and man is inside the bus in a happy mode. This is at t equal to not 0. This is at t equal to t. Okay, at t equal to t, man is inside the bus. Now initially man is here and we have assumed that after time t, man catches the bus. This is the distance traveled by the man. Okay, SM, M for man, distance traveled by the man. That is equal to Vt. This is the distance traveled by the bus. Now acceleration is 2.5 meter per second square, which is constant. Initial velocity is 0. Use second equation of motion. That is S is equal to ut plus half at square. Now u is 0, so it is only half into 2.5 into t square. Got? This is distance traveled by the man. This is 45 meter. This is SB. Now from this figure, it should be clear to everyone that is distance traveled by the man is equals to 45 plus distance traveled by the bus. Obviously, man was initially 45 meter behind the bus. If for the same time interval he wants to catch the bus, then he has to move extra 45 meter as compared to bus to catch the bus. So SM is Vt, that is equal to 45 plus half. Okay, half. 2.5 is 5 by 2 t square. Okay, so this is 5 by 4, that is 1.25 t square minus Vt plus 45. That should be equal to 0. Now we have to find the value of V. Now to have real solution. The meaning of this statement to have a real solution, that is for the real value of t. The value of t should be real. Then only man can move the bus. Otherwise, if t comes out to be complex, that is virtual. Complex. Okay, complex. That is negative. Then how come men will able to catch the bus? So t should be real, not imaginary. For that, d, that is discriminant, should be greater or equal to 0. That is b square minus 4 ac greater or equal to 0. You are getting this? If you have a quadratic equation like ax square plus bx plus c equal to 0, then the discriminant is equals to under root of b square minus 4ac. Okay. Now to have a real solution, here a is 1.25, b is minus b and c is 45. So v square should be greater or equal to 45 into 4 is how much? 0 to 180, 1.25. That is v should be greater or equal to 15 because it comes out to be 225. So the question is asking minimum value of v, that is equal to 15 meter per second. A very good question. Okay, option number 3rd is the correct answer. That is the man should start moving with a minimum velocity of 15 meter per second if he wants to board the bus. Got? Option number 3rd is the correct answer. Next one is, a spring balance is attached to the ceiling of a lift. A man hangs his bag on the spring and the spring reads 49 Newton. When the lift is stationary, okay, if the lift moves downward with an acceleration of 5 meter per second square, the reading of the spring balance will be. Okay, that is the reading of the spring when the lift is stationary is given as 49 Newton. The question is asking the reading of the spring when the lift is moving downward with an acceleration of 5 meter per second square. Okay, let's start doing the question. This is the lift. This is a spring balance. And there is a bag of mass M. Okay. This spring will measure the tension in the spring. That will be the reading. Okay. Or the spring force. Okay. Because tension will be equal to the spring force. Spring force, not spring constant. Spring force. And that spring force is equal to Kx. That is equal to tension and that is equal to reading. Okay. Mg is acting like this. Tension is acting like this. So when lift is stationary, reading is equals to mg and that is equals to 49 Newton. This is given. Okay. Now lift starts moving downward with acceleration of 5 meter per second square. Mg is still acting downward. Tension is moving upward. Tension is not moving. Tension on the block is on the bag is in the upward direction, and that tension will be reading. Okay, this is not the same T. This is, let's suppose, T dash, the new tension. Okay, now block is moving downward. Mg is acting downward, tension upward, and the block is moving downward. So net force in the direction of motion, that is net force in the downward direction, is mg minus T dash is equals to ma. So T dash, which is equals to the reading, is equals to m g minus a. So mg is given as 49 Newton. So from here, mg is equals to 49 Newton, we can calculate the value of m. Let's calculate. Mg is equals to 49. So m is equals to 49 upon 9.8. Okay. We can write it as m is equals to 490 upon 98. That is how much? This is 2. So this is 10 upon 2. That is equals to 5 kg. Okay, mass is 5 kg. Just put the value, get the answer. 5. This is 9.8 minus 5. Okay. Now from the 49 Newton, it should be clear that it should be 9.8, not 10. G should be 9.8. And whenever in the question G is not given, always try to take G as 9.8. Yeah, it will make your calculation a bit harder, but fine. To get the exact answer, you have to take 9.8. Now 9.8 minus 5 is 4.8. That is T dash is equals to 4.8. It is 0.424. So the new reading is 24 Newton. Wow, that is option number 1. Okay, that is the correct answer. Next one is, the force acting on a particle moving along x-axis varies with the position on x-axis as shown in the figure. Okay, this is F versus position graph. Okay, the particle is in stable equilibrium at x equal to x minus x1, x equal to x2, x equal to 0, both 1 and 2. Okay, that is, we have to identify for what value of x the particle is in stable equilibrium. Okay, now to be in stable equilibrium, first of all, F should be equal to 0 to be in equilibrium. Okay. Now obviously F is 0 at x equal to minus x1 and x equal to plus x2. But we have to find the position where it will be in stable equilibrium. Okay. So to be in stable equilibrium, df by dx, that is equal to slope, should be negative. Okay. Now slope is tan theta. Just draw the tangent at x equal to x2. Here theta is less than 90. Slope is equals to tan theta, which is positive. Now here, draw the tangent. Now theta is this, greater than 90. So slope is negative. So slope is negative at x equal to minus x1. So df by dx is negative at x equal to minus x1. So it will be in stable equilibrium at x equal to minus x1. That is option number 1 is the correct answer. Next one is, a body of mass m is moving with constant velocity parallel to x-axis. Okay. The angular momentum with respect to origin increases with time, decreases with time, does not change, none of above. Okay. This is the coordinate system. Particle of mass m moving with constant speed parallel to x-axis. This is x, this is y. So parallel to x-axis, that is particle is moving on this line. Mass is m, and let's suppose it is moving with velocity v. Okay, first of all, what is angular momentum? Okay, so mod of angular momentum is equals to momentum, that is p, into perpendicular distance of line of motion from axis of rotation. Not ration, it is rotation. Okay, axis of rotation. Okay, this is very important expression, very important expression. Okay, perpendicular distance of line of motion. Line of motion is what? Line of motion is obviously the line along which the particle is performing motion. So this is the line of motion, this is the line of motion. Line of motion. And we have to write the angular momentum about origin. This is origin. So the perpendicular distance of line of motion from origin is this much, d distance. And it remains same throughout the motion of the particle. When particle is here, the line of motion is having a perpendicular distance from the axis of rotation, that is origin is d. When particle will reach here, line of motion is still same. So the perpendicular distance of line of motion from origin is still d. So if d remains same, so the mod of angular momentum is mb, and this is d, and it remains d whether the particle is here, moving on any line. It remains same. The perpendicular distance of line of motion, perpendicular distance, okay, of line of motion from axis of rotation remains same. So angular momentum will also remain same. So option number 3 is the correct answer. The next one is, a bomb of mass 9 kg explodes into two pieces of 3 kg and 6 kg. Okay, the velocity of 3 kg piece is 16 meter per second. The kinetic energy of 6 kg piece is, okay, now there is a bomb. Total mass is 9 kg. Now it explodes. Now explosion is because of the internal chemical reaction, that is, there is no external force acted on the system. F external is equals to 0. And whenever there is no external force acted on the system, the linear momentum of the system remains constant or conserved. So if one particle of mass 3 kg moves in this direction, let's suppose with speed 16 meter per second, then the remaining mass should move in the opposite direction, that is 6 kg should move, let's suppose, with velocity v in the opposite direction, because initial momentum should be equal to final momentum. Now as the bomb initially at rest, that is initial momentum is 0, so the final momentum should also be 0. Now if one particle is moving in this direction, then the remaining particle should move in this direction, then only they can cancel each other's momentum, and hence the final momentum will also be 0. Got it? F external is 0. So P of the system is constant or conserved. Got it? That is P initial is equal to P final. Initial momentum is 0. Final momentum is 3 into 16. Now, as I have written the momentum of this as mv, that is plus mv, that is I have considered this direction as positive. So, I have to consider this direction as negative, minus 6 into v. Good. So, 6v is equals to 3 into 16. This will cancel this by 2 times. This further cancel this by 8. So, v comes out to be 8 meter per second. That is, the 6 kilogram piece will move with a speed of 8 meter per second and in the opposite direction in which 3 kilogram piece was moving. So, the kinetic energy of 6 kilogram piece is half m v square. Good. This cancel this by 3 times. So, kinetic energy is equal to 3 into 8 square is 64. So, this is 2, 1, 18 plus 1 is 19. So, kinetic energy is 192 joule. 192 joule, that is third option is the correct answer. This is a very typical question, that is very standard problem based on the conservation of linear momentum. Got option number third.
Hello guys, let us solve this question. A constant torque of 31.4 Newton meter is exerted on a pivoted wheel. If the angular acceleration of the wheel is, it is alpha is what? Alpha is 4 pi radian per second square. Okay. Now, then the moment of inertia of the wheel is, as we know, torque is what? Torque is I alpha. So, I is equal to torque upon alpha. So, torque is 31.4 upon 4 pi. Pi is 3.14 cut by 10 times. So, it is of 2.5 kilogram meter square. Okay. So, first option is the correct option. Thank you very much.
The next one is, a 5 kilogram body collides with another stationary body. After collision, the bodies move in the same direction with 1/3 of the velocities of the first body. Okay. After the collision, the bodies move in the same direction with 1/3 of the velocities of the first body. The mass of the second body is. Okay. That is, after collision, both the bodies are moving with the same velocity. Or you can say after collision, though it is not given in the question, but after collision they are moving with the same velocity. It is only possible when they stick together and move with the same velocity. So, this is an example of perfectly inelastic collision, perfectly inelastic collision. Okay, so first draw the diagram. This is 5 kilogram. Let's suppose moving with velocity u. This is another body of mass m. Initial velocity is 0. After collision, 5 plus m moving with a velocity of v by 3 in the same direction. This is before collision and this is after collision. Good. Now, collision is an isolated event, that is, momentum should be conserved. P initial should be equal to P final. So, 5 into u plus m into 0 is equals to 5 plus m into u by 3. Not v by 3, it is u by 3. Okay, 1/3 of the initial. So, it is 5u is equals to 5 plus m into u by 3. Now, u will cancel this u. Just cross multiply. So, 5 into 3 is equals to 5 plus m. That is 15 is equals to 5 plus m. So, m is equals to 15 minus 5. So, mass of the second body is 10 kilogram. So, option number 2 is the correct answer. Got it? The next one is, match list 1 with list 2 and select the correct answer Find the potential energy in the following. Okay, list 1 we have to match list 1 with list 2. Okay, what is the potential energy, expression of potential energy of two particles, mass m1, m2, separated by distance r, is minus g m1 m2 upon r. That's it. Okay, so start writing one by one. A u1 is equals to minus g, m1 is 2m, m2 is m, upon separation is 3r. So u1 is equals to minus 2gm square by 3r. Where is minus 2gm square by 3r? Here. So A matches with 4. A matches with 4 is only in option number 1. So obviously option number 1 should be the correct answer. But we'll write the potential energy for B, C and D also. So for B, U2 is minus G, M1 is M, M2 is M, upon separation is 4R, 4R. Okay, so U2 is equals to minus Gm square by 4R. Minus Gm square by 4R, that is B will match with third. B is matching with third, correct. Now comes C. That is solid sphere of mass m and a point particle of mass m, but that point particle is situated outside the sphere. And for any position outside the sphere, whether the sphere is solid or hollow, the sphere will going to behave as a point particle placed at its center. Okay, so U3 is equals to minus G m m upon separation is 3r. So U3 is equals to minus Gm square by 3r. So third will match with second. Okay, now comes the D. Again hollow sphere, but the point is another mass is situated outside the sphere. So the hollow sphere will be going to behave as a point particle of mass m, same mass placed at the center. So U4 is equals to minus G m into 2m upon separation is 5r. So U4 is equals to minus 2gm square by 5r. Got it? Where is this? Obviously, it should be the first one. D matches with first. So option number 1 is the correct answer. Next one is, the mean distance of Mars from Sun is 1.5 times that of Earth from Sun. Okay, what is approximately the number of years required by Mars to make one revolution about the Sun? Okay, the distance of Mars is given as 1.5 times as compared to the distance of Earth, both from the Sun. Okay, so the question is asking about the number of years required by Mars to complete one revolution. As we know, the options are all are in years, and we know that the time taken by Earth to make one revolution, one complete revolution around Sun is 1 year. Okay, so use Kepler's law from Kepler's law that T square is directly proportional to R cube. T is the time period and R is the mean distance, or we can write T directly proportional to R power 3 by 2. Got it? Now for Mars or for Earth, that is, or we can write T Mars upon T Earth is equals to R Mars Sun upon R Earth Sun power 3 by 2. Okay, so T Mars upon T of Earth is 1 year. Okay, 1 year. The distance of Mars to Sun is given as 1.5 times as compared to the distance of Earth and Sun. Let be that distance is R, so it will be 1.5 R power 3 by 2. R will cancel R. So time of revolution for Mars is 1.5 power 3 by 2. That is 1.5 into root of 1.5. It comes out to be 1.85 years. Okay, 1.85 years. That is option number 2 is the correct answer. Got it? Next one is, if the tension on a wire is removed at once, then just look at the options. It will break, its temperature will reduce, there will be no change in its temperature. Fourth is its temperature increases. That is mainly the question wants to know about the effect on the temperature. Okay, so when tension is removed, there is a wire, and there is a tension in this wire. Now tension has been removed suddenly. Okay, so when tension removed, then the molecules of the wire will come close to each other, because of which intermolecular force increases. Now potential energy is a negative function of intermolecular force. IMF is intermolecular force. Now as intermolecular force increases, and because of this negative sign, potential energy decreases. And this decrease in the potential energy will appear in increase in the heat energy. The decrement in the decrease in potential energy will be equal to the gain in heat energy. And because of which temperature will increase. Its temperature increases. That is option number 4 is the correct answer. A very good question, conceptual question. The next one is, a body floats in water with its 1/3 volume above the surface. Okay, the same body floats in a liquid with 1/3 volume immersed. Okay, in first case 1/3 volume is above the surface, and in second case 1/3 volume is immersed. Okay, the density of liquid is 9 times more than that of water, 2 times more than that of water, 3 times more than that of water, and 1.5 times more than that of water. Okay, first it is floating in water. Okay, so volume or the fraction of volume immersed. Okay, let's suppose that fraction is represented by small f, and that is equals to density of the body upon density of liquid. Okay, so this is how we write the fraction. Now the density of the body, whether it is immersed in liquid, whether it is immersed in water, density of this body remains same in both the cases. So we can write that the fraction of volume immersed, or fraction of volume immersed can be written as that inversely proportional to the density of liquid, rho L. Got it? So for water, fraction is F, and that is inversely proportional to density of water. Got it? Now fraction of the volume immersed. In this water floats in water with 1/3 volume above the surface. So 1/3 volume above the surface, then what is the volume immersed in the surface? Okay, and that is equals to V is the total volume. So volume immersed is, now 1/3 is above the water, so volume immersed is how much? 2/3. Okay, so it will be V minus V by 3 upon V, that is inversely proportional to density of water. So it is 2 V by 3 by V, that is inversely proportional to density of water. V will cancel V, so 2 by 3 is inversely proportional to density of water. Hold it. Now for liquid, okay, for the liquid, now 1/3 volume is immersed, so fraction of the volume immersed is 1/3, that is V by 3 by V, that is inversely proportional to density of liquid, or 1 by 3 is inversely proportional to 1 upon density of liquid. Now divide them. Okay. here, divide them. So what we'll get is 1 divided by 2. So 2 by 3 by 1 by 3. 2 by 3 by 1 by 3 is equals to 1 by density of water upon 1 by density of liquid. 3 will cancel 3. So 2 is equals to, this will go in the numerator, rho L by rho W. Or we can write this is as density of liquid is twice the density of water. So the density of liquid is 2 times more than the density of water. That is option number 2 is the correct answer. This is based on the fraction of volume immersed. Okay, fraction of the volume immersed is the volume immersed upon total volume. So in the case of water, 1/3 of the volume is above the water surface. So 2/3 is immersed. So the volume immersed is 2V by 3 upon total volume is V. So the fraction will be 2 by 3. That is 2V by 3 upon V. In case of liquid, 1/3 is immersed. So how we calculate the fraction immersed? That is the volume immersed upon total volume. So V by 3 upon V. Okay, V by 3 upon V. Got it? We have just divided this and got the final answer as rho liquid is twice time of density of water. Option number 2 is the correct answer. Next one is, there are 2 parts of a vessel. The pressure in one part is P and its volume is V. Pressure of one part is P and volume is V. The volume of the another part is 4V and there is vacuum in it. If the intervening wall is ruptured, then the work done by the gas and the change in its internal energy will be. Okay, that is, it will be ruptured. Now, question is asking about the work done. This is a very good question based on the free expansion of the gas. Okay, so first calculate the work done. Work done by gas. How we write the work done by the gas? Is P delta V or PdV. Now what is this P is? This should be known to everyone. This is very important. This P is external pressure. Okay, external pressure. Now, if we'll talk about the external condition, here vacuum. Now on the another part, there is vacuum. That is, no molecule is present. So if no molecules are present on the another part of the container, then obviously pressure here is 0. That is, external pressure is 0. So the gas is expanding against 0 pressure. And when gas expands against 0 pressure, we call it as free expansion. Free expansion. Got it? So P is 0 for vacuum. So work done will also be 0. Usually you had seen that the value of PdV equal to 0 because of the constant volume, dV equal to 0. But this is the special condition when work done is 0 because pressure is 0. Okay. So first volume, work done will be 0. So obviously option number 1 and option number 2 cannot be 0. Okay. Now just look at the next part is pressure. One part is this. This is 4V. Now as work done will be 0. So from float, first law of thermodynamics. Nothing has been given about the container, whatever the container is. So dW plus du should be equal to 0. So as dW is equal to 0, du should also be equal to 0. Got it? So both are 0. So option number 4th is the correct answer. Okay, that is in free expansion for the ideal gas, temperature also remains same because internal energy is constant. This is the change in the internal energy, not the internal energy. Internal energy is constant, hence the change in the internal energy will be 0. That's why option number 4th is the correct answer.
Hello guys, let us solve this question. The temperature at which the RMS velocity of oxygen molecule is equal to that of nitrogen molecule at 100 degrees centigrade. So V oxygen is equal to V nitrogen at 100 degree centigrade. Okay. Now V is what? It is under root of 3RT upon MW. Molecular weight of oxygen is what? It is of 32 gram. So convert it into the kilogram, and it is equals to under root of 3R, and T is 100. So 100 plus 273 upon nitrogen. Molecular weight of nitrogen is 28 gram. Okay guys. Now square both side. Now 3R to 3R cancel out. 10 minus 3, 10 minus 3 cancel out. So T upon 32, that is equals to, it is 373 upon 28. It is cut by 7 times. It is cut by 8 times. So T is what? It is 373 multiplied by 8 upon 7. Okay. Now just solve it. It is of 3.2. Now just multiply it 6. It is a 24. 8 5 is 40 plus 242. So almost 424.6 or 426.3. Accurate is 426.3. So correct answer is first, it is of 426.3. Thank you very much. Hello guys, let us solve this question. A particle performing SHM having amplitude A possesses the velocity 3 under root 3 by 2 times the velocity at mean position. As we know, V at mean position is what? It is maximum. It is A omega. Okay, so V is equal to a general formula under root of A square minus X square. Now, the displacement of particle will be, so V is what? It is of A omega multiplied by under root 3 by 2, and that is equal to omega under root of A square minus X square. Omega to omega cancel out and square both sides. So 3A square by 4, that is equal to A square minus X square. So X square equals to A square by 4. So X is what? It is of A by 2. Okay, so correct option is first, it is of A by 2. Thank you very much. Hello guys, let us solve this question. A siren emitting sound of frequency, it is of 800 hertz. Okay, going away from the static listener with a speed of, so velocity of source, that is of 30 meter per second. The frequency of sound to be heard by the listener, as the source is moved away from the listener, so N dash is apparent frequency is NV upon V plus Vs. Okay, so N dash is what? Here V is the speed of sound, it is 330. So N is what? It is of 800. So 800 multiplied by 330 upon 330 plus 30. Now just solve it. So 800 multiplied by 330 upon 360. 1112. Now just solve it. It is of 733.3 hertz. So correct answer is third. It is of 733.3 hertz. Okay guys, thank you very much.
The next one is a number of capacitors, each of capacitance 1 microfarad and each one of which gets punctured if the potential difference just exceeding 500 volt is applied, are provided. Then an arrangement suitable for giving a capacitor of capacitance 3 microfarad across which 2000 volt may be applied requires at least 4 component capacitor, 12 component capacitor, 48 component capacitors and 16 component capacitors. Component capacitors is basically capacitors only, that is 4 capacitors, 12 capacitors, 48 capacitors and 16 capacitors. That is the breakdown potential of the capacitor is given as how much? 500 volt. But we have to apply 2000 volt. Now in series arrangement of the capacitors, potential divides. Okay, and in parallel arrangement, charge divides. So obviously, one capacitor can stand up to 500 volt potential, but we have to apply 2000 volt potential. So there must be 4 capacitors in series. Got C, C, C and C. All are having a value of C equal to 1 microfarad. 500 across this, 500 across this, 500 across this, 500 across this, that is 2000 volt can be applied across the arrangement of these 4 capacitors in series. First condition has been matched. The second condition is we required the equivalent capacitance of the arrangement as 3 microfarad. Now 1 microfarad, 1 microfarad, 1 microfarad, 1 microfarad. All are in series, so their equivalent is 1 by 4 microfarad. 1 by 4 microfarad. What we want? We want 3 microfarad as the equivalent capacitance. That is, we have to increase the capacitance. When you make series arrangement, then capacitance decreases, and in parallel arrangement capacitance increases. What is the equivalent capacitance of these 4 capacitors in series arrangement? 1 by 4 microfarad. We want 3 microfarad. Okay, that is, we have to make the parallel arrangement. So keeping these 4 capacitors in series. So the next is like this. C, 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 C. Now this is C by 4. Now this is C by 4. Now C by 4 and C by 4 are in which arrangement? In parallel arrangement. So the capacitance increases. Okay. So how many branches we have to make for this? This is 1 by 4, 1 by 4 and 1 by 4. Parallel. So it will be 1 by 2. Now this is one branch, this second branch. The equivalent of the first 2 branches is 1 by 2. Now the third branch. Okay, so it will be how the capacitance increases. 4. Now after 4 branches, C by 4, 1 by 4, 1 by 4, 1 by 4, 1 by 4. 4 branches. Equivalent will be 1. We want equivalent as 3. So there should be total 12 branches. 12 branches. Getting this? Branches. The potential across each is 2000 volt. So 1 by 4, 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 all are 1 by 4, 1 by 4 microfarad 12 times in parallel. So their C equivalent will be 12 into 1 by 4 microfarad. That is 3 microfarad. Got. So total capacitors will be 4 into 12. That is 48 capacitors required. Got. So option number 3rd is the correct answer. Got. The next one is a wire has resistance 12 ohm. It is bent in the form of a circle. The effective resistance between 2 points on any diameter of the circle is. Okay. This is a wire and the total resistance is given as 12 ohm. R is equal to 12 ohm given. Okay, now it is bent to form a circle. Okay, the question is asking about the effective resistance or the equivalent resistance between the 2 diametric ends. Okay, now total resistance of this whole wire is 12 ohm. Now it is divided into 2 parts. Upper semicircle and lower semicircle. So as length becomes half, so resistance will also be half because resistance is equal to rho L by A. So length becomes half length this, half length this. So resistance will also becomes half. So 6 ohm here, 6 ohm here. Now 6 ohm and 6 ohm are in parallel and R equivalent in parallel arrangement is R1 R2 upon R1 plus R2. So R equivalent is equal to 6 into 6 upon 6 plus 6. So it is 36 upon 12. That is equal to 3 ohm. So the equivalent resistance for the any two diametric ends for this arrangement is 3 ohm. That is option number 4 is the correct answer. The next one is a 100 watt and 200 volt bulb is connected to a 160 volt supply. The power consumption will be, okay, this is rated power and rated voltage is given. Now from rated power and rated voltage, we can calculate the resistance of the bulb. Okay, now P rated is equals to V rated square upon R. Okay, so R is equals to V square rated upon P rated. That is 200 square upon 100. That is 200 into 200 upon 100. So R comes out to be 400 ohm. Resistance of the wire is, resistance of this bulb is 400 ohm. The question is asking if the supplied voltage is 160 volt, then what is the power consumed? So power consumed. P is V square by R. So V is 160. So 160 into 160 upon 400. 1 0 cancel, 1 0 cancel. So it is 16 into 16 by 4. This is 4. So it is 16 into 4. That is 64 watt. So the power consumption will be 64 watt for the supply of 160 volt. That is option number 3rd is the correct answer. Got it? The next one is a straight wire of diameter 0.5 mm carrying a current of 1 ampere is replaced by another wire of diameter 1 mm carrying the same current. The strength of the magnetic field far away is, okay. So this is the wire. This is the wire. Okay. And at a distance R, outside the wire, the magnetic field is mu naught I upon 2 pi R. Okay, where small r is the distance of the point from the axis of the wire. Now this is independent of the diameter of wire. Since it is independent of the diameter of the wire, the magnetic field will remain same, whether the diameter is 0.5 mm or it becomes 1 mm. Okay, magnetic field will remain same. So option number 4 is the correct answer. The next one is a short bar magnet of magnetic moment 0.4 joule per Tesla is placed in a magnetic field of 0.16 Tesla. The magnet is in stable equilibrium when the potential energy is. Okay, the question is asking again the potential energy. Now the potential energy is given as minus m dot b. M is magnetic moment and b is the magnetic field. It is given that it is in stable equilibrium. It is minus m b cos theta. Okay, now for stable equilibrium, theta should be equal to 0 degree. That's the only possibility. Then the potential energy will be minimum. And when energy is minimum, that is the condition to attain the stable equilibrium. So theta is 0. So potential energy is equal to minus mb cos 0, which is equal to 1. So it is minus mb. Now m is how much? 0.4 with a negative sign. B is how much? 0.16. So the potential energy is equals to minus, this is 16 into 4 is 64. So it is minus 0.16 0.064 joule. Minus 0.064 joule, that is option number 2 is the correct answer. Got it? Next one is the magnetic flux linked with a coil given by equation phi is 8t square plus 2t plus 20 Weber. Okay, the induced EMF in the coil at the end of the second will be. Okay, just look at the option. All the options are positive. That is, question wants us to calculate the magnitude of the induced EMF. Now the magnitude of the induced EMF is rate of change of flux. So it is d phi by dt. So d by dt of this 8t square plus 2t plus 20. So induced EMF is equals to 16t plus 2. Okay, t square is 2t. Differentiation of t with respect to t is 1. 20. Okay, I am writing this 0. Okay, differentiation of constant is 0. So it is 16t plus 2. Okay, now add t equal to 2 seconds. Induced EMF will be 16 into 2 plus 2, that is 32 plus 2, that is equal to 34 volt. 34 volt is the value of the induced EMF at the end of the second. Got it? So option number 3 is the correct answer. Next one is alternating current is flowing in inductor L and resistance R. Okay, that is, it is LR circuit. The frequency of the source is F, that is omega by 2 pi. Which of the following statement is correct? For low frequency, limiting value of the impedance is L, which is inductance. It is dimensionally incorrect. Okay, impedance cannot be equal to the inductance. Both are having different units. For high frequency, the limiting value of the impedance is omega L. Okay. For high frequency, the limiting value of impedance is R. For low frequency, the limiting value of the impedance is omega L. That is, from the option, the question is talking about the impedance. Now for LR circuit, impedance is under root of R square plus omega L square. Okay. Now look at the option number 2 for high frequency. That is, omega is high. Omega is high, then the limiting value of the impedance is omega L. Now when omega is high, okay, that means omega L will be very greater than R. So we can neglect this R square here. That is, Z is limiting value is approximately equal to under root of 0 square plus omega L square, and that is equal to omega L. That is, option number 2 is the correct answer. We'll discuss option number 3 and 4 also. For high frequency, the limiting value of the impedance is R. No, it is omega L. For low frequency, the limiting value of the impedance is omega L. We'll discuss this fourth option. Low frequency, omega is low. Now square of low is very low. So this omega L will be negligible in comparison with R, because resistance of the resistor is independent of the frequency. So the fourth option, if you want to make the fourth option as correct option or correct statement, then for low frequency omega L is 0. So the impedance is, limiting value of the impedance should be equal to R, not omega L. Here it is omega L. So this is incorrect. Option number 2 is the correct answer.
Okay, so the question says that in a simple microscope of focal length 5 cm, final image is formed at the least distance of distinct vision, then its magnification will be. Now, whenever you talk about a simple microscope, the magnification when the final image is formed at capital D is given as 1 plus capital D upon F. Now once you have understood, let us substitute the values. So the value of D is 25 centimeter and the focal length of the simple microscope is given as 5. So this comes out as 1 plus 5, which is equal to 6. Now once you have got this, the final answer to this particular question is 6, and let us match this answer with the options given in the question. Now looking at the options, I can say the first is correct, the second is wrong, the third is wrong, and the fourth is wrong, and hence the final answer for this particular question comes out as option 1. And I hope each and every one of you have understood the question as well as the concept behind this particular question in the solution and the explanation provided to you. Thank you.
Moving to the next one. In an interference experiment, two parallel vertical slits S1 and S2 are used. That is, question is talking about Young's double slit experiment. A thin glass plate is introduced in the path of light from S1. Then, just look at the option, fringe pattern remains unaltered. Second is fringe pattern as a whole is laterally shift towards S1. Third is fringe pattern as a whole is laterally shift towards S2. Fourth is fringe width decreases. Okay, now the experimental setup is like this. S1 and S2 are two slits, and this is screen. Okay, now according to the question, you have placed a glass plate in front of S1. Now, in front of S1. Okay, here you have placed a glass plate. Now, according to YDSC, that is Young's double slit experiment, if a sheet has been placed in front of a slit, then the whole pattern of the whole interfering pattern shift towards that side where you have placed the sheet, that is towards S1. So this is initially the central bright fringe, central bright. Okay, now the whole pattern will shift towards S1, that is in the upward direction. S1 doesn't mean that the pattern will shift here like this. No. We are observing the interference in light, and obviously interference in light will observe on a screen. So it will shift towards upward direction. Got it? So the pattern will shift laterally towards S1. So option number 2 is the correct one. Now the fourth, let's discuss option number 4 also. Fringe width beta is equals to lambda d by d. Lambda is the wavelength of the light used. D is the distance between slit and the screen, and small d is distance between the slits. Now, as the distance between the slits remains unchanged, because by placing a glass plate in front of S1, this distance remains unchanged, so the beta will remain constant. This is wrong. So option number 2 is the correct answer. Next one is, what is the stopping potential for photoelectrons ejected from a metal of work function 1.2 electron volt when the incident light consists of photons of energy 1.8 electron volt? Okay, now the work function is 1.2 electron volt and energy of the incident ray is 1.8 electron volt. These are the given things. Okay, now according to Einstein equation of photoelectric effect, equation, energy incident on the surface, partially that energy is utilized as work function, that is the amount of energy required to bring an electron from inside to till the surface, and the remaining as the form of the kinetic energy of the photoelectrons. The question is asking about the stopping potential, and the maximum kinetic energy of the emitted photoelectrons is basically the measurement of the stopping potential. Okay, this is the equation Kmax. Now Kmax is equal to EV naught. Okay, where V naught is stopping potential. what the question is asking. Good. So energy is 1.8 electron volt. Work function is 1.2 electron volt. I am writing the value of Kmax as EV0. Now E all cancel out. That is 1.8 volt is equals to 1.2 volt plus V0. So V0 comes out to be 1.8 minus 1.2 volts. So V0. So V0 comes out to be 0.6 volt. 0.6 volt, that is option number 1 is the correct answer. A very simple question based on the conservation of energy, which is given by the Einstein. And Einstein got the Nobel Prize for this equation. Okay. Our answer is option number 1, 0.6 volt. The next one is, in a hydrogen atom, the electron in a given orbit has total energy minus 1.5 electron volt. The potential energy is, okay, total energy is given as minus 1.5 electron volt. Okay, this is given. Obviously, system is bounded, that's why the total energy is negative. Now, this is a very, very important question. Okay, so try to remember the equation whatever I'm writing for this question. Okay, we know that total energy is basically the sum of the kinetic energy and potential energy. So kinetic energy plus potential energy. Okay, first equation. Now kinetic energy is equal to minus of total energy. Okay, kinetic energy can never be negative. Total energy is negative. Negative will become positive. Okay, second equation. Potential energy is equals to 2 times the total energy. Okay, total energy is negative, potential energy is twice the total energy, so potential energy is also negative. Obviously, potential energy negative. This confirms that the system is bounded. That's why satellite, electrons, whoever is revolving, okay, that shows that system is bounded. Okay, now from this we can also write that kinetic energy is equals to minus of potential energy by 2. Okay, from this equation you can easily understand, divide these two equations, you will get this relation 4. Okay, now total energy is given and the question is asking potential energy. Now we have potential energy and the total energy, how they are related is twice the total energy. So potential energy is 2 times minus 1.5 electron volt. So potential energy comes out to be minus 3 electron volt. Minus 3 electron volt, that is option number 4 is the correct answer. Got? Try to remember all these expressions. First is known to you, second, third and fourth, all are important. Okay, option number third, minus 3 electron volt is the value of the potential energy and the option number 4 is the correct answer. Got it? The next one is, a positron of 1 mega electron volt collides with an electron of 1 mega electron volt and gets annihilated, and the reaction produces 2 gamma ray photons. Okay, if the effective mass of each photon is 0.0016 AMU atomic mass unit, then the energy of each gamma ray photon is about. Okay, that is, we have to calculate the energy corresponding to 1 photon. Okay, now the mass of the photon, effective mass, okay, not the rest mass of photon is 0. Effective mass of the photon is given as 0.0016 AMU. Okay, as you know that energy corresponding to 1 AMU is equal to 931 mega electron volt, and this is energy corresponding to mass of 1 AMU. Now we have to calculate the energy corresponding to 0.0016 AMU. So the energy of one photon of mass 0.0016 mu, that will be equal to 0.0016 multiplied by 931 mega electron volt. Okay, so it is 931 multiplied by 16. Okay, then we'll place the decimal till 4 places. Okay, so it is 6, 8, 1, 54, 55, then 1, 3, 9. So it is 6, 9, 8, this 4 places. So it is 1.4896 mega electron volt. 1.4896 mega electron volt is approximately equal to 1.5 mega electron volt. So option number 1 is the correct answer. This is the energy corresponding to the 1 gamma ray photon emitted during this process in which the effective mass is 0.0016 mu. Got it? So our answer is option number 1. Next one is statement 1. The number of electrons in a p-type semiconductor is less than the number of electrons in the pure silicon semiconductor at room temperature. Statement 1 is correct. That's why we call it p-type semiconductor, where the concentration of holes is greater than the concentration of electron. If concentration of electrons is greater than the concentration of hole, then instead of p-type, we'll start calling it n-type semiconductor. So statement 1 is correct. Now the statement 2 is, it is due to law of mass action. That is also correct. As number of holes are greater, so both the statement 1 and 2 are correct. So both the statement are correct. That is option number 4 is the correct answer. Moving to the next one. If the energy gap between valence band and conduction band is 5 electron volt, then it should be an insulator. Okay, options are conductor, semiconductor, superconductor. Obviously, if superconductor, then no question. Okay, so typically energy gap for conductor, that is approximately equal to 0. No energy gap. Okay, approximately. Okay, for semiconductor, it is approximately equal to 1 electron volt. And for insulator, obviously it is greater than that of the semiconductor. So typically the energy gap for insulator lies between 3 to 5. Okay, I am writing it for insulators. It is approximately 3 to 5 electron volt. So it comes under this. So clearly an insulator. So option number 2 is the correct answer. The next one is, in the given circuit, calculate the ratio of currents through the batteries if 1, key K1 is pressed, K2 open, and then 2, that is the second case in which we have to calculate the current. Key K2, this is K2 is pressed and key K1 is open. Okay, key 1 is open and K2 is closed. Okay, so one by one we'll calculate first current I1. Okay, when key K1 closed and K2 open. Okay, now K1 closed and K2 open. This is closed, this is open. So this battery is not the part of the circuit. This is positive terminal of the battery. This is connected with p-type. Okay, and this is N. So this is forward biased. And this is P is connected with N. This is reverse biased. So this diode is forward biased. This diode is reverse biased when K1 is closed and K2 is open. Okay, I'm writing. They have not mentioned the diode's name, so I'm writing. D1 is this diode, D2 is this diode. So K1 closed, K2 open, D1 is forward biased and D2 is reverse biased. In forward biased, the diode will provide almost zero resistance, and when reverse biased, the diode will provide infinite resistance. Okay, so this will provide infinite resistance, so current will not pass through this. How the current will flow? Current will flow like this. Like this. That is, the circuit will be like this. 10 ohm, 5 volt battery, current is I1. So I1 is equals to 5 upon 10, that is equals to 0.5 ampere. Okay. Now comes the second case, when K2 is closed and K1 is open. Okay, K2 is closed and K1 is open. So obviously, this 5 volt battery is not the part of the circuit. Okay, this is negative terminal. Negative terminal is connected with the negative terminal. This is D1, this is D2. So negative terminal is connected with N side. So this is forward biased. And this negative terminal of the battery is connected with P side. So this is reverse biased. So D1 is reverse biased and D2 is forward biased. Got it? Okay. So this is forward bias, that means, and this is reverse bias, that means no current through this branch. So how the circuit will look? The circuit will look like this. This will offer zero resistance. That's why I can draw a conducting wire only. 20 ohm and 10 volt battery. Current is I2. Okay. So I2 is equal to 10 upon 20. That is 1 by 2, that is 0.5 ampere. Again, I2 is also 0.5 ampere, I1 is also 0.5 ampere. The question is asking I1 by I2, that is 0.5 by 0.5, that is equal to 1. So the ratio is 1. So option number 4 is the correct answer. A good question. Okay. Diodes are involved, and also you will come to know that how the battery can be a part of the circuit and cannot be the part of the circuit. Option number 4 is the correct answer. The next one is the de Broglie wavelength of a neutron at 27 degrees centigrade is lambda. Okay, what will be its wavelength at 927 degrees centigrade? Okay, we have a de Broglie wavelength for neutron at 27 degrees centigrade, and the question is asking the de Broglie wavelength at 927 degrees centigrade. Okay, now de Broglie wavelength. The expression is given as lambda is equals to h upon p. H is Planck constant and p is momentum. Now momentum is, we can write how momentum can be related with the energy. Kinetic energy is equals to p square by 2m. That is the relation between energy and the momentum. So p can be written as under root of 2m into k. Okay. Now as far as this neutron is concerned, now here the question is talking about the temperature, so we can consider neutron as a molecule or as a particle. So we can write the kinetic energy as a function of temperature, How we can write? It is 2m. Kinetic energy can be written as 3 by 2 kT. K is Boltzmann constant. Okay, this will cancel this. So P comes out to be under root of 3m kT, and T is absolute temperature. Absolute temperature means temperature in Kelvin. Okay, I'm writing here so that no one will confuse that this is Boltzmann constant, not the kinetic energy. Boltzmann constant. Okay, so lambda is equals to h upon p. Now p is 3m kT. I'm writing this here in Kelvin. Okay, now start with the problem. Okay, start with the problem. Initially wavelength is given as lambda and temperature is 27 degrees centigrade. 27 degrees centigrade is 300 Kelvin and 927 degrees centigrade is 1200 Kelvin. That is plus 273. So it is h upon under root of 3 mk into 300. Now let's suppose at 927 degrees centigrade wavelength becomes lambda dash h upon under root of 3 mk 1200. Now divide 2 from 1, that is lambda dash by lambda. This is h upon under root of 3 mk into 1200 upon h upon under root of 3 mk into 300. Got it? Now h will cancel h, 3 mk will cancel 3 mk. This will go in numerator. So lambda dash by lambda is equal to under root of 300 by 1200. That is 1 by 4. Now 4 will come out from the root. It will be 1 by 2. So the lambda dash by lambda is 1 by 2. Or we can write lambda dash is equal to lambda by 2. Lambda dash by is equal to lambda by 2. That is option number 1 is the correct answer. Got it? Next one is the dispersive powers of the material of two lenses are in the ratio of 4 by 3. Dispersive power, that is W1 by W2, is given as 4 by 3. Given. If the achromatic combination of these two lenses in contact is a convex lens of focal length 60 centimeter, then the focal length of the component of the lenses are, okay, that is, this is 60 centimeter is the focal length of the combination, okay, for the combination. So for combination, now it is known to us that for achromatic combination, two lenses should be used of the opposite nature. If one is convex, then another should be concave. Okay. So for combination, 1 upon f is equals to 1 upon f1 plus 1 upon f2. Now if f1 is positive, that is for convex, then f2 should be negative, which represents a concave lens. So this is 1 upon 60 is equal to 1 upon f1 plus 1 upon f2. Got it? Now for achromatic combination, for achromatic combination, W1 F1 plus W2 F2 should be equal to 0. Or we can write it as W1 F1 is equals to minus W2 F2. Got it? That is W1 by W2 is equals to minus F2 by F1, and W1 by W2 is given as 4 by 3. So if we'll talk about the magnitude only, from this it is clear that if F1 is positive, then F2 should be negative. That is, the nature of both the lenses should be opposite. So if we'll only talk about the magnitude, that is 4 F1 is equal to minus 3 F2. Getting this? Or F1 is equals to minus 3 F2 by 4. Now put this value in this equation. What we'll get is 1 by 60 is equals to 1 upon F1 is minus 3 F2. 4 will go in the numerator like this, plus 1 upon F2. Okay. So 1 by 60 is equals to 3 F2. So it is minus 4 plus 3. So 1 by 60 is equals to minus 1 by 3 F2. This will cancel this by 20 times. That is, F2 is equals to minus 20 centimeter. Minus 20 centimeter. So the focal length of one lens involved is minus 20 centimeter. That is, option number 2nd and option number 3rd cannot be the correct answer. Now F1. So the value of F1 is minus 3 by 4 times of minus 20. Minus minus will cancel. This is 5, that is 15 centimeter. So the focal length is plus 15 and minus 20, that is option number 4 is the correct answer. Got it? Now the next one is, a planar coil having 12 turns carries 15 ampere current. The coil is oriented with respect to the uniform magnetic field of B as 0.2 I cap Tesla, such that its directed area vector is minus 0.04 I cap meter square. This minus sign is with the I cap. That is, the area is towards the negative x-axis. The potential energy of the coil in the given orientation is, okay, question is asking about the potential energy. Now first, let's draw the coil. This is the coil. Number of turns are given as 12 and carries a current of 15 ampere. Now this is the magnetic field of 0.2 I cap Tesla. Area is negative. That is, it carries a current like this, so that the area is in this direction, like this. Okay, so I am writing the area with a negative sign. Otherwise, if I'll indicate the area in this direction, then there is no point of placing a negative sign because this is negative x-axis. So I'm 0.04 I cap meter square. Now the question is asking about the potential energy. Now the potential energy is minus m dot b, that is magnetic dipole moment into magnetic field dot product of them with a negative sign. Now m is n I a dot b, or we can write the potential energy as minus n I a dot b. Now clearly magnetic field in this direction and area vector is in this direction. Magnetic field in this direction, area vector is in this direction, so the angle between them is 180. Now dot product of a dot b is ab cos theta. So it will be minus n I a b cos 180. Now cos 180 is minus 1. Now minus minus will become plus, so it is n I a b. That is the potential energy. Now obviously this will be positive, so option number 4 cannot be the correct answer. 0 is no possibility. So either second or third can be the answer. Just put the value, get the answer. Number of turns 12. Current is 15. Area is how much? 0.04. And magnetic field is 0.2. Got it? 12 into 150 is 180 into 0.008. So it is 0.18 into 8. Got it? So 18.8. It is 144. So it is 1.44 joule. So the potential energy is positive 1.44 joule. That is option number 3 is the correct answer. Got it? The next one is, two bars made of same material are connected as shown in the figure. An electric current is passed through the bars. The resistance of the bar PQ, where is PQ? PQ is R1, while the resistance of QR is R2. Then look at the options. We have to find the relation between R1 and R2. Now the resistance is rho L by A. This is the resistance. Rho is the resistivity. L is that length along which current is flowing. And A is the area of cross section of the wire perpendicular to which current is flowing. Got it? So radius of the wires are given as 2R and R. Okay, so I am writing the value of R1 first. Material is same, so rho will be same because resistivity only depends on the material. Rho is rho. Current is flowing like this. So for this PQ wire, length is 2L. Area is pi into 2R whole square. hold it. R2 is rho. L is how much? L pi r square. Got it? Now divide them. R1 by R2 is equals to rho into 2L upon pi into 2R square upon rho into L upon pi R square. Got it? So rho L, pi, R square. Oh, so many calculations. So many cancellations. So it is 2 by 2 square. That is 2 by 4. That is 1 by 2. So we get R1 by R2 as 1 by 2 or 2R1 is equals to R2. That is R2 is equals to 2R1. That is option number 1 is the correct answer. Got it? The next one is the electric potential in volt due to an electric dipole of dipole moment 2 into 10 power minus 8 coulomb meter at a distance of 3 meter on a line making an angle of 60 degree with the axis of the dipole is. Okay, that is we have to calculate the electric potential at an angle of 60 degree with the axis of the dipole. Axis of the dipole is, that is, this is q and this is minus q. So this is the dipole, the electric dipole moment direction is from negative charge to positive charge. Okay, so we have to calculate somewhere here. Okay, let's suppose here, this angle is 60 degree. So how the potential is, can be written as, it is Kp cos theta by r square for any orbit position or any general position. K is 1 upon 4 pi epsilon, value is 9 into 10 power 9. P is electric dipole, how much? Its value is 2 into 10 power minus 8. Theta is given as 60, so it is cos 60. And the distance r is how much? 3 meters. So 3 square. Good. Now 3 square is 9. 9 will cancel this 9. So V is equals to 10 power 9 into 2 into 10 power minus 8. Cos 60 is 1 by 2. This 2 will cancel this 2. Good. So it is 10 power 9 into 10 power minus 8. That is equals to 10. Okay. So the answer is 10 volt. That is option number 2 is the correct answer. Got it? The next one is, consider the following two statements. A is total electric flux through any closed surface is always 0. Total electric flux through any closed surface is always 0. This is statement number 1. B is electric field due to an electric dipole is uniform. Which of the following option is correct? Now obviously the electric field due to electric dipole is not uniform. At different places it will be different. Okay, so this is a wrong statement. So B is wrong. Now just look at the option number, the A statement. Total electric flux through any closed surface is always 0. That is incoming flux is equal to outgoing flux. So this option number A is correct. So A is correct, B is incorrect. A is correct, B is incorrect. So option number 1 is the correct answer. Got it? The next one is, a standing wave having 3 nodes and 2 antinodes is formed in the string of length 1 meter. Okay, length of the string is also given as L is equals to 1 meter. The wavelength of the standing wave is, question is asking the wavelength of the standing wave. There are 3 nodes and 2 antinodes, all given. So like this is the standing wave. These are 2 rigid ends. Now for sure, node here, node here. Okay, there are 3 nodes. That means 1 node is in between them. That means 2 loops are there. Node, total 3 nodes. This is antinode, this is antinode. 2 antinodes. So the figure will be like this. Okay, there will be total 2 loops. Now length is given as L and that is equal to 1 meter. Now node to node is lambda by 2. Node to node is lambda by 2 and node to this node is also lambda by 2. So total is lambda by 2 plus lambda by 2, that is equal to lambda, and that is equal to L, which is given as 1 meter. So the wavelength of the standing wave is given as 1 meter. That is option number 3rd is the correct answer. Got? Now moving to the next one. A mass m1 connected to a horizontal spring performs SHM with amplitude A. Okay. While mass m1 is passing through mean position, another mass m2 is placed on it so that both masses moves together with amplitude A1. Okay, that is initially when only m1 is performing SHM, amplitude was A, and while passing through the mean position, another mass m2 is placed over it. Now they are performing SHM but with the amplitude A1. The ratio of A1 by A2, that is the present amplitude to the past amplitude. We have to calculate the ratio. M1 is greater than M2. Okay, fine. It only shows that M1 is greater than M2, that is both will continue doing SHM. So initially, this is the spring. Let's suppose this is spring. Okay, horizontal spring. And this M1 is performing SHM, having an amplitude A. Spring constant is K. So the total energy is equals to half K A square. Okay. Now the question is talking about the ratio of the amplitudes. Now spring constant K remains same, or the force constant you can also say. Now how you can write this expression in terms of mass, because question is talking about the mass. Just look at the options in terms of m1 and m2. So now K can be written as, where I should write this, yes, here. K is basically m omega square. M is mass and omega is angular frequency. So it is half m1 omega square A square. Okay. When m2 is placed over it, the total energy equals to half m1 plus m2. Frequency remains same, but the amplitude will become A1 square. Now there is no external force acted on the system, so the energy will remain conserved. Okay, so from conservation of energy, that is initial total energy and the final total energy should be same. That is half m1 omega square A square is equals to half m1 plus m2 omega square A1 square. Now half will cancel this half, omega square will cancel this omega square. So basically m1 A square is equals to m1 plus m2 into A1 square. Got it? Now question is asking A1 by A2. A1 by A2. Okay. So we can further write it as, here I am writing A1 square upon A2 square. Not A2, it is A. Okay. A square. A1 square by A square is equals to M1 upon M1 plus M2. So A1 by A2 is equals to under root of M1 upon M1 plus M2. Good. So obviously option number 1 is the correct answer. The question is very simple, but the language is like that, or like some rocket science is involved in the question. No, the important thing in this question is only write the value of force constant or the spring constant in terms of mass of the block and the angular frequency. Okay, in terms of the option, I can write it as A1 by A2. A1 by A2 as M1 upon M1 plus M2 whole power 1 by 2. Got? Option number 1 is correct answer. Got? The next one is, if 1 kilogram air, gamma is given as 1.4, which is equals to the gamma for diatomic gas, because mostly air is made up of diatomic gases, oxygen and nitrogen, is heated adiabatically from 0 degree to 10 degree centigrade, then increase in its internal energy will be CV given as 0.172 calorie per gram per degree centigrade. Okay, that is gram specific heat at constant volume is given. The question is asking about the increase in the internal energy. Now, increase in internal energy is du. Now, whatever be the process, if the change in the temperature for any system is dt, then the increment in the internal energy will always be equal to m CV dt. M is the total mass. Got? Now, mass in kilogram, but just look at this CV. CV is 0.172 calorie per gram per degree centigrade. Now, this you have to change this per gram into per kilogram. Okay, that is, it is 0.172 calorie. Now, gram will be converted into kilogram per degree centigrade. So, it comes out to be 172 calorie per kilogram per degree centigrade. Got it? So, mass is 1, CV is 172 into dt is how much? 10. So, it is 1720 calorie. This is the value of du. Okay, 1720 calorie, 172 joule, 172 joule. This cannot be the answer. So, obviously, no option is matching with this 1720 calorie. So, we have to convert it into joule. So, obviously, only one option is there in joule. So, there is no point of multiplying it by 4.2. Directly tick on the second option and move on the next one. Okay. This is the way to save the time during the exam. But here I'm telling you how to calculate. This is 1720 into 4.2 joule. Okay. By multiplying 4.2, you will convert calorie into joule. So, it is 172 into 42. So, 172 into 42 is 4, 3, 8, 2, 6. So, 4, 12, yes. Oh, exact, we are getting the exact answer. 7224 joule. So, obviously, option number 2 should be the correct answer. Got it? Next one is, a hollow and a solid sphere of same material and having identical outer surface are heated under identical condition to the same temperature at the same time. Identical condition to the same temperature at the same time. Okay, their final temperature, they'll attain the same temperature in the same time period. Okay. So, they both have same E, that is emissive power of both the hollow and the solid sphere is same. Obviously, as the material is same, then the emissive power should also be same. Just look at the option so that we'll come to know that what the question wants to know. First is, in the beginning, both will emit equal amount of radiation per unit time. Second is, in the beginning, both will absorb unequal amount of radiation per unit time. Okay, one is emit, one is absorb. Okay. Both spheres will have same rate of fall of temperature dt by dt, that is rate of cooling. Fourth is, both spheres will have equal temperature at any moment. Okay. That is, now from the Newton's law of cooling, okay, or from Stephen Boltzmann law, you can do by either of them. So I'm using the Stephen Boltzmann law. Rate of cooling or rate of heat absorbed first, dq by dt is equals to ms t power 4 minus t naught power 4. Okay. Now under identical condition, that is T naught is same for both, but mass is different. Mass is different. Good. Now mass is different and one is hollow and one is solid. Same material in outer surface. So obviously, now for the same size, mass of solid will be greater than mass of hollow sphere. Okay. So and up to final temperature is same. That is, this capital T is same, T naught is same. Okay. So what should we write? From Stephen Boltzmann law. This dq by dt is directly proportional to t power 4 minus t naught power 4. Okay, or dq by dt is Stephen constant E t power 4 minus t naught power 4. Got. Now as t naught E same for both, so they will emit equal amount of radiations initially, that is at the beginning. Why at the beginning? Why not after that? Because both are having different rate of cooling. Okay, rate of cooling. Rate of cooling is d theta by dt, and that is equal to 1 upon ms dq by dt. Now we have the value of dq by dt, so it is sigma E t power 4 minus t naught power 4 upon ms. Now m of solid is greater than m of hollow. Now as both the spheres are having different masses, so their rate of cooling or rate of fall of temperature is different. Now when rate of fall of temperature is different, then just after t equal to 0, this T will be different for both the spheres. And though the final value of T will be same for both, okay, but the variation in T will be different. Got it? So T will be different after T equal to 0 for both the spheres. Now as T will be different for both the spheres, this T will be different for both the spheres. So this rate of absorption or emission of heat, radiation, will also change. So they can only have the same rate of emission of radiations same at the beginning only. That is option number 1 is the correct answer. Got it? Next one is the moment of inertia of an annular disk of mass m, capital M, outer and inner radii r and r by 2 about its diameter. Okay, this is an annular disk. Okay, here mass is present and this portion is vacant. Okay, no mass. Inner radius is, let's suppose, r, and the outer radius is r, and inner radius r is equals to r by 2, that is equals given. Then moment of inertia, that is mi, of this annular disk about diametric axis is equals to m r square plus small r square by 4. This is the expression of moment of inertia of annular disk about diametric axis. This capital R is the outer radius and small r is the inner radius, and inner radius is given as r by 2. Got it? So I is equals to m by 4 r square plus r by 2 whole square. Got it? So I is equals to m by 4 r square plus r square by 4. That is 5 mr square by 16. 5 mr square by 16 is the moment of inertia of this annular disk of outer radius r, inner radius r by 2 about diametric axis. Option number 3 is the correct answer. Next one is a force F is equals to 20 plus 10y x on a particle in y direction where F is in Newton and y in meters. Work done by this force to move the particle from y equal to 0 to y equal to 1 meter is. Okay, variable force is given and the question is asking about the work done from y equal to 0 to y equal to 1 meter. Now, how to calculate work done by a variable force? By integration. Okay, so dw is equal to f dy. Just integrate from with the proper limits. Here y equal to 0 to y equal to 1. So w is equals to f is 20 plus 10y dy. Limit is from 0 to 1. So work is equals to 20. Integral dy is y. Limit is vary from 0 to 1 plus 10. Integral y dy. Integral y dy will be y square by 2. Y square by 2. Limit is from 0 to 1. This will cancel this by 5 times. So work is equal to 20. 1 minus 0 plus 5. Y square is 1 square minus 0 square. That is 20 plus 5. 25 joule. So work done by this force 20 plus 10y in moving the particle from y equal to 0 to y equal to 1 is 25 joule. That is option number 3 is the correct answer. Next one is a block of mass 1 kilogram is at rest on horizontal table. The coefficient of static friction between block and the table is 0.5 and g is equals to 10 meter per second square. Then the magnitude of the force acting upward at an angle of 60 degree from the horizontal that will just start the block moving is. Okay, let's draw the diagram first. This is a block. Mass is given as 1 kilogram. 1 kilogram. Okay. Force is acting like this. We have to calculate this force, which is acting at an angle of 60 degree with the horizontal. So this is F cos 60 and this is F sin 60. This is 1g, that is mg, and this is normal reaction. Obviously this F cos 60 will try to move the block in the horizontal direction. So obviously friction will act in the backward direction, Fl. And the value of Fl should be equal to mu n. Okay. So first we have to calculate the value of n. And mu is given as 0.5. First calculate, whenever friction is involved in the numerical, it is always advisable to calculate the normal reaction first. Okay. Just as the block has to move in the horizontal direction, equate upward force with the downward force. That is n plus F sin 60 is equal to 1 into g. Because the block will be in vertical equilibrium. Vertical equilibrium, that is upward forces should be equal to downward forces. So n is equals to 1g, that is equals to g minus F root 3 by 2. Hold it. Now to just start the motion, F cos 60 should be greater or equal to FL. Okay, I am not placing the inequality sign, I am placing equal sign, FL. Okay, and FL is equal to mu n. So F cos 60 is how much? 1 by 2 is equal to FL is mu n. Mu is how much? Okay, I am writing first mu n. N is 10 minus F root 3 by 2. This is root 3. F root 3 by 2. Got it? Now the value of F mu is 0.5, that is 1 by 2. So F by 2 is equal to 1 by 2. 10 minus F root 3 by 2. This 2 will cancel this 2. So F is equal to 10 minus root 3 by 2 F. Take F term here, so it will be F 1 plus root 3 by 2 is equals to 10. That is f is equals to 2 into 10 upon 2 plus root 3. That is 20 upon 2 plus 1.7. That is 20 upon 3.7. Now 20 upon 3.7 is equals to 5.36 Newton. Okay. So option number 2 is the correct answer. That is the value of the force. That is the value of the force which is required to start the motion of this 1 kilogram block on a horizontal surface having a coefficient of friction as 0.5. Option number 2 is the correct answer. Next one is, two particles of equal masses are revolving in a circular path of radii r1 r2 respectively with same period. Okay. The ratio of their centripetal forces. Okay. m1 is equals to m2. Okay. T1 is equals to T2 given. Now as T1 is equals to T2, we can write T is equals to 2 pi by omega. Omega is angular frequency. So we can also write omega 1 is equals to omega 2. The question is asking the centripetal force. Now centripetal force is equals to mv square by r or m omega square r. Okay. So F1 is equals to m1 omega 1 square r1 and F2 is equals to m2 omega 2 square r2. Divide them. m1 equal to m2, omega 1 equal to omega 2, that is F1 by F2 is equals to r1 by r2. So the ratio of their centripetal forces are in the ratio of their radii. That is option number 1 is the correct answer.
Hello guys, let us solve this question. The resistance R is what? V upon I, where V is this and I is this. The percentage error in R is where R is what? It is a V upon I. We may write as V multiplied by I to the power minus 1. So delta R by R we may write as delta V by V minus delta I by A, and we take the maximum possible percentage error, that is delta R by R is what? It is delta V by V and plus delta I by I. Okay. Now delta V is what? Delta V is 5 and V is 100. So it is of 5 upon 100 plus delta I is 0.2, 0.2 upon 10. So it is of 2 by 100. Multiply by 100 for percentage error. So delta R by R in percentage, it is equals to 5 plus 2 is 7%. So correct answer is third, it is of 7%. Okay guys, thank you very much.